Building cloud-native applications is really great. We get the power of the cloud to scale out, high availability, and we're able to do a lot of things that we would not be able to do very easily without the cloud and some of the managed services. But the downside is development sometimes is very difficult. Starting up an environment, you need to connect to all these services. And in this example, I'll mention some of the challenges that I've been experiencing and just how I've used Docker to start up things very easily without having to configure my environment locally. So recently, I've been doing a lot more development on a web API backend service. So this is a basic ASP.NET backend service, and I've been having a bit of trouble running it and debugging it locally. And I guess the first thing you'd think is surely you can just run it in Visual Studio or Rider and start it up, right? What's the complexity? But the complexity is more around all the services that it calls and the various things. So the first thing is the front end is a separate single page application, which is Angular, and it's hosted on a CDN. But so for development, we'd have to fire up a front end and to be able to test it fully. Of course, you can just test the API without it, but to get the full end-to-end, you'd need to test it with it. And then we've got a NoSQL data store, which then you need to reference that, Azure Table Storage. And obviously, since this is a managed service in Azure, it means you also need to start something up locally. And along with the other Azure storage pieces, there's some blob and queues and all the other things. Plus, we've got a whole host of third-party external API services that we also need to call from this API. And as any API that's scalable and that really focuses on performance and optimization, we've got a cache, Redis cache as well. So as you can see already, this is just firing up a local application. It's got references to a whole host of things. And not just that, but we have the external APIs that we call, but then there's also the internal services that we also make reference to. And think of it as similar to a bit of a microservice setup where various systems in the ecosystem and services, we need to reference them and they reference us as well. And so suddenly developing locally and testing something becomes rather difficult. So fortunately, the external APIs are easy enough. We can simply, when developing locally, we can point to the same API endpoints and refer to those. So if we get rid of that for local development setup, because that's straightforward. And similarly, we've got the other services in the ecosystem, the internal ones that we refer to. They are API endpoints hosted on a development environment, which we can simply reuse. Looking at the three different areas that we need to cover when we do local development or startup, is the first is the Azure storage. And since Azure storage is a Azure hosted or managed resource, developing locally, you either need to point to a managed resource in the cloud, or you need to run a local emulated version. Then looking at Redis cache, in the production one, we're using a managed Redis cache instance, but you also have, if you want to develop locally, once again, you need to install this locally and run it locally to be able to develop against it. And lastly, we've got the single page application, which is an Angular app, which is running separately. And that's something we can fire up with a ng-serve. And we don't really need that if we're just using the API server, because we can just look at the contracts that we've defined with the API and make sure that we return based on the API calls. But it does make it a lot easier when testing full end-to-end, especially when putting multiple things together. We can install npm or node, for instance, which then well, you can install the packages and you can start this up, and you can install the emulator and then start up the emulator, and you can install Redis and you can fire that up, as well as then running your API. So, but once again, this is fairly tedious, and if you are just wanting to develop the API, the other services are really just there to aid your development within that API. So the way I've decided to solve this is to define a Docker Compose YAML file, and that just helps simplify things to put the containers I want to fire up, and I can do a Docker Compose up and tear it down again with Docker Compose down. And so here you see the three services I've declared is the web app, that's the Angular application I need. Then there's the Redis, that's the cache, and then this is the storage, or the storage emulator. So the first image I'd like to look at is the Redis one, and fortunately on Docker Hub there is a Redis image for us for this exact use case already, so that helps a lot. And by default our registry is Docker Hub, so when we refer to image Redis, if we go to Docker Hub for instance and we type Redis, we'll find an image, and this is the official image from Redis. And so what I've done then is to look at the ports that I need to expose, and so I've just used the latest. There's no tag, and usually what you can do is supported tags respective Docker file links. If you don't see the port in here, what you can do is you can just go to the Docker file, is what I've done, and you can have a look down here and see what the Redis image that was built. This Docker file exposes the port 6379, and so in the Docker Compose YAML file, I've also just simply fire up the Redis, the latest, because it's got no tag, and then expose the 6379, which is the one we need to expose internally, and then externally, just to keep things simple, just use the same one as well. Looking at the Azure storage, fortunately there is an image that I did find from Microsoft called Azurite, and this is basically a containerized emulator. And once again, if we go to Docker Hub, we can search for that. So I'll search for Azurite, and over here we can check it out. So if we pull this image, so that's what I've done over here, and there's various ports that it exposes. So in the documentation it does show to expose some ports. Here it says 10,000 is the blob, 10,001 is the queue, but it doesn't mention anything about table storage. So what I've gone and done once again is you can go to the Docker file. Unfortunately I didn't see any links directly from the tags, but you can go to the repo. Thank goodness for open source. And then you can go to the Docker file. Once again, you can look at the Docker file that builds Azurite, and in here you'll see table storage exposes 10,002. So then going back to the Docker Compose file, I've exposed those three ports. Once again, just keeping it simple. The inside and outside kept it on the same port. There's a small difference between the Redis image and the emulator, and that is over here. I haven't used any volumes, but for the Azure one I have. So what this basically means, once again, is when a container starts up, it basically you run it, and everything that happens within that container, basically the state that you have, the moment that you tear it down again, that state is lost, and all the data within it is lost as well. And for Redis, I don't really care, because it is temporary data, and so every time I start it up again, I don't mind having a fresh instance. However, with the storage emulator, that would be pretty annoying if your table storage data, or your queue data, or blob storage, whatever you want to refer to, suddenly disappears every time you start and stop this app. You'd have to set it all up again. So what you can do is, if you go to the site again, just go back over here to the Docker Hub one, and usually any decent documentation will tell you where the data is persisted within the container. So for instance over here, so if you looked inside the container, you would see the data is stored over here. So under data.mcr. So what I've gone and done is your storage is a named volume, and I basically created a volume, and this is a separate thing that does get created. When you tear down the Docker Compose file, the named volume will stay. So what this means is I create the volume, then I appoint this specific directory to that volume, which means every time I tear the container down and start a new one up, this volume persists. So the data that was saved there persists, and every time then I can continue with it. I know the documentation does indicate a bind mount over here in the example, but in this case I didn't actually feel the need to go after the actual data on disk. So I don't care where the data is, I just care that it's persisted. So I went for the named volume there. And lastly, looking at the actual Angular application, that was the third part. What you'll see over here is I'm referring to an actual image, and it's a decision I made. You can firstly create the Docker file. This is what I've done. It's a Linux-based Node image. Unfortunately, Node doesn't have Windows containers images. So if you do want to run it on Docker for Windows, you can. It just does make it a little bit tedious, since you would have to create maybe your Nano server, and then you'd have to do an explicit install of Node. It's very manual. Whereas this, for instance, is already nicely packaged. We just refer to the base image. We're doing Node.js version 14. So copy the package JSON file, created the app, the work directory in the container, copy the JSON file, package JSON file, do an npm install. And just something to note here is it didn't copy everything over. So the reason is when the package JSON file changes, it'll need to run this again, and npmi or npm install does take a while sometimes to run. And so if you do this and you first do the npm install, which creates all your node modules, and thereafter do the copy, what this means is if you change any file in the Angular application, these steps will be unchanged, and therefore they'll be cached and not run again, and it'll only start running from here. So we won't do the npm install every time. If, for instance, we copy every time and it detects that since the last build some file has changed, therefore it will always run the npm install. So it's just a little small thing there. We expose the port 4200, and then we do an npm start. And so that's a very, very straightforward, there's nothing special to this Docker file for Angular. And so the idea is then to hook this up to the CI/CD, and every time we push any changes to the latest master branch, for instance, we can build this, upload it to the container registry, either in Azure or Docker Hub, and once that's hosted, then it means I can always run my Docker Compose file, and I'll always get the latest version if I do it with the CI/CD. The other option would have been to do the actual build in here, so let the Docker Compose do the build and start it up. But I went for the other approach. I felt that it's less to worry about, and knowing that you'll always run the latest version of the web app is quite useful, without having to rebuild it every time on your end. So in this case, so this would point to the registry it uploaded it to, but in my case I've just run it locally. So it's just a sorry, this is the called web app, and this would run if I look at the current images that I do have, a current image list, I've got Redis, web app. There we go. So this is the image that it's currently pointing to. So the image name is that, the container name will be that as well, appended with obviously the prefix of the Docker Compose. But ports, once again, same as before. The only difference here is what I've done is I've added volumes and basically binding mounts, and the reason for that is it allows me to if you look in the same directory, so I've got the Docker Compose and I've got the environment file and the flags file, and there are environments default and flags that are default within the web app, but it does give me the files. Basically, I'm saying when you refer to the environment file inside the container, rather refer to my file on my machine, and vice versa. Whenever you refer to the flags file inside the JSON, refer to this file here. And there's obviously other ways you can do this with environment variables rather than actually having external files. It's probably better, and then creating an environment file maybe, or but these are two files that we typically change and customize, and therefore I just wanted to keep it very similar and separate like that. And now all we need to do is literally just fire it up, Docker Compose up, and this will run through the YAML file. It'll create first create the volume if it doesn't exist already, and then create the different containers. So I should probably have run Docker container up -d, a detached mode. So now, unfortunately, my terminal is bound to this, which is okay. But the nice thing if you run in detached mode is you can at any stage just carry on doing your commands. Now I'll need to open a different command. But what you'll see is if you go to your Docker desktop, is it when we run Docker Compose, it groups a couple of running containers, which is quite nice. And there you'll see Redis is up and running, Docker Compose up and running, and the web app. The web app does usually take a little bit longer. Starting up Angular, you'll see a bunch of it's busy compiling, and once that's up and running, all three of these should be good to go. And while the web app is busy starting up, what we can do is just check whether the other two are good to go. So if I go into my Storage Explorer, you'll for instance see we've got an emulator over here under storage accounts, and we will be able to just refresh. And for instance, now if I create a table, for instance, now I've obviously just started it, so there are no tables. I would need to run migrations or something like that first. Test, and here I've got my first NoSQL entry, about to create something, partition key, row key, very useful. There we go, and that's up and running. And if I were to stop this and start this again, you'd actually see that it persists because of the volume that I created for that. So if I say stop over here, and so now if I go over here and I say refresh, you'll see connection issue. Now the containers, if I start it up again, in this case I didn't remove the container, but you're just going to have to trust me there if you remove it as well because of the volume. And you can check the volumes over here, and here's the volume, that the Azure storage one, the named volume. Some of these are anonymous volumes, but yeah, the important one is this, and that makes sure that if I create a new container, it's a complete fresh container, but the data will persist because it's on that volume. And now if I refresh again, you'll see table storage up and running again, and I can continue to query and use it. Let's quickly have a look and see if the Redis is up and running correctly. We can see that the container is started, and that's fine. But what we can do as well is we can do docker container list. And we see there's our Redis, this container over here. You can obviously also do docker ps though. Whoopsie, if not like that. The older command which does the same. But so what we can do now is oopsie, actually needed that. So we go docker execute interactive terminal, and we can say the 176, the Redis one. And what do we want to run? So Redis CLI ping. So that's just a Redis command to check if everything's up and running, and we get a response back, pong. So that's all good. That's working. And lastly, by now, we should be able to see that the web app is up and running. So we can over here just have a look at the logs. And there we go. You'll see it's compiled successfully, and we're up and running. And so we've got our Redis image from Docker Hub that's up and running. Every time the container will stop or be removed, then we lose the state, and that's fine. We've got our Azure storage emulator, and we've connected a named volume there, which allows us to just keep that volume around and persist the data. And lastly, we've got our Angular application, and we just doing a starting up that from there. We built that from a Docker file using the node image with version 14, but with the standard parameters, just to get an Angular app up and running for development environment. Just to note, if you're doing production, you do it slightly differently. You wouldn't just do an npm start. You do a build, for instance, and just to optimize a few things there. So it's purely for development, this, but we got our application up and running, and which is great. And now what we can do is, if we wanted to tear it all down again, we simply hit docker compose down, and everything will be gone. And as easy as that. Now we don't have to manage the containers individually. When we're ready to develop our web API application, we simply fire up this docker compose up. It starts everything. We start developing, and when we're done, we just tear it all down again. There are obviously different ways to solve this problem. I mean, the one way would be to have a hosted or managed instances of, for instance, the storage or Redis, where you could just simply point to those. The benefit of that is it's available wherever you are, and it's always there, and it's a lot closer to production. The downside is that you would have to create that for every developer that wants to work on it. They'd have to have their own individual instances that they have to host. So it might be a management or a cost issue depending on what services you run. And I mean, there are obviously other ways of running PowerShell scripts, starting everything you need to start up. But with PowerShell scripts, once again, you end up installing everything on your local machine, which isn't exactly a problem, especially if you're going to be using this development environment quite a lot. Having everything installed locally is perfectly fine. It just is great to be able to start it up, tear it down, and I mean, even on this machine, I mean, we were able to run a Angular application. But if I say node, for instance, here, it's not installed. So we don't have those installations on this machine. However, within the container, we have that because of we pull the image, which is everything that we need. Yeah, and so that's it.